Welcome to the Micromodule series, Understanding Bias in Epidemiological Studies. In this module, we will be focusing on information bias arising from outcome detection procedures, also known as detection bias. The objectives of this module are to illustrate how information bias may arise from outcome detection procedures with a hypothetical cohort study and introduce how to address the bias. Detection bias, also called ascertainment or assessment bias, occurs when there are systematic differences between groups in how the outcome is detected, determined, or identified. Consider a study investigating whether occupational exposure to pesticides is associated with peripheral neuropathy, which is the outcome of interest. How may detection bias occur in this study? In the exposed group, there is a higher likelihood that pesticide workers will report symptoms like numbness and tingling because they are aware of the potential risk. Furthermore, their doctors might conduct more thorough neurological tests, such as nerve conduction studies, due to their knowledge of the participants' exposure history. On the other hand, in the unexposed group, individuals may experience similar symptoms but attribute them to other causes, such as aging or diabetes, and thus not seek medical evaluation. Even if they report symptoms, doctors may not conduct specialized tests, leading to underdiagnosis. As a result, the study overestimates the association between pesticide exposure and neuropathy because cases are more likely to be detected in the exposed group, even if the true risk is similar in both groups. So, how do we minimize detection bias in epidemiological studies? Here are 3 key strategies. Firstly, conduct blinded outcome assessment. Ensure that the doctors assessing the outcomes are unaware of the exposure status of the participants. This reduces the chance of bias based on preconceived knowledge. Secondly, ensure equal follow-up and assessment. Both the exposed and unexposed groups should receive similar follow-up and diagnostic assessments. This ensures that both groups are equally likely to have their outcomes detected. Thirdly, use objective diagnostic criteria. Implement standardized and objective diagnostic tests for all participants, irrespective of their exposure status. This helps to ensure that the same diagnostic criteria are applied to both groups, reducing the likelihood of bias. Okay, in this module we discussed how information bias may arise from outcome detection procedures and explore the strategies to address it. In the next module, we will begin a new chapter on confounding bias, where we will learn about its mechanisms through an illustrative example. Thank you for listening.